All right, we're now going to work through our review. First problem on our review is important for us. There is going to be a problem like this on our 6-week test, so you probably want to understand how to do this one. All right. First thing we always want to do is we want to write down what our A, B, and C values are. Before we do that, I'm going to go ahead and I'm going to factor out a -1 out of this formula, because if it is a negative squared term, you want to make it positive. So when I factor out a -1, what I am left with is positive x squared minus 2x, okay, minus 24. All right. So this is the equation we're going to be dealing with. So for this case, A is equal to 1, all right? We have B is equal to -2, and our C value is equal to -24. All right? Our axis of symmetry, the way we calculate that is we do x is equal to -b over 2a. Now we're going to plug in information. -b is a positive 2 over 2a, which is 2 times 1 is 2. So our axis of symmetry is x is equal to 1. All right. Now our vertex is our axis of symmetry x value, so that's 1. And what we do in order to find the y value of our vertex, we take the function evaluated at our x value. When we do that, we are going to get that number is equal to -1. Well, let's put it in here. I'm sorry. We have our -1, and we're going to do 1 squared minus 2 times 1 minus 24. All right, 1 squared is 1, minus 2 is -1, and we subtract 24 more, we get -25, and then we multiply it by the -1, and we get a value of positive 25. So our vertex is going to be at 1, 25. All right. Our y-intercept, well, that's given. That's our c value. And our c value is equal to -21, but we need to pay attention to the fact that we still have this -1 factor out here. So our y-intercept is going to be at 0.24. To find the roots, what we do is we're going to factor our equation. So I'm going to rewrite our equation. We have -1 times x squared minus 2x minus 24. We can do the old ACB method. So our factors are of -21 that add up to -2. And our factors that add up to -2 are going to be -6, +4. All right, -6 plus +4 gives us a -2, and a -6 times a +4 gives us a -24. Therefore, our factors are x minus 6 and x plus 4. Solving this, we find that x is equal to 6, and when we set this equal to 0 and solve, we get x is equal to -4. Okay, this should be an equal sign. So our roots are -4, 0. Remember, we always write them in coordinate form. And our other root is positive 6, 0. All right. Now all we need to do is come over here and graph it. We know our axis of symmetry is at positive 1. So at positive 1, we have our axis of symmetry. Go ahead and draw a dotted line showing that that's your axis of symmetry. We know our y-intercept is at 0, 24. So I'm just going to put a mark way up here at the top and say, excuse me, this is 0, 24. All right. That's our y-intercept, so we'll go ahead and put a point here. We now know our roots are at negative 4, 0, 1, 2, 3, 4. We're going to put a point here. And our positive root is at 1, 2, 3, 4, 5, 6. We put a point here. We only have one more point to put on our graph, and that is going to be at our vertex. Sorry about that, but if you're here, Deshanti, you can go home. All right. So we're going to put a point at our vertex, and our vertex we found was at 125, so I come way up here. That point there is our vertex. It's at 125. We now have the points that we need. We're going to go ahead and draw our graph. Okay. And we come around the other direction. And we have our vertex. The A value is negative 1, and our graph is pointing down. So everything looks about right. We're going to go ahead and now we're going to write our range down and our domain. Our domain for a quadratic equation is always going to be all real numbers. Our range, our minimum value is the graph approaches negative infinity. Okay, that's why we use the parentheses. And it goes up to a maximum value of 25. And we use the square brackets. So we have now solved the first problem. This is the one that seems to give y'all the most problems. If it happens, you're going to always be using fractions. In this case, it didn't happen, so don't worry about the fractions. Okay, problem number 2 is presented as a word problem. Write the equation of quadratic function with roots of negative 4 and 0. When it says negative 4 and 0, a root is where it crosses the parabola crosses the x-axis. So we know our root, one of our roots is at negative 4, 0, and our second root is at positive 4 and 0. All right? And it has a y-intercept of 8. So that means the coordinates of this guy is 0, 8. All right. Now that we've identified our information, we need to use the root form of the quadratic equation. And I'll go ahead and write it down to help you guys remember what it is. The root form is f of x is equal to a times x minus root 1 times x minus root 2. All right. We need to solve for a, so we're going to take the information that's given and plug it into our equation. All right. We were told that the y-intercept was 8, so I'm going to write 8. We're solving for a, and we're going to plug in 0 for x minus root 1, which is a negative 4, so that changes that to a plus 4. And then 0 minus root 2, which gives us 0 minus 4. Okay. We do the basic math. We have 4 times a negative 4 is a negative 16. So we have negative 16a is equal to 8. Divide and simplify, and we get a is equal to negative 1/2. Now all that's left to do is to plug in to our equation. Our root form of the equation, we have f of x is equal to a, which we just calculated, negative 1/2, times the quantity x minus root 1, which is x plus 4, and x minus root 2, which gives us x minus 4. We now have solved problem number 2. Moving on, once again, we're going to write down the information they give us. This one is very similar to problem number 2. We have our root value is negative 5, 0, and our other root is positive 1, 0. Our y-intercept is negative 1, so we have 0, negative 1. Take our information and plug it into the root form of the equation. And when we do, we get negative 1 is equal to a times 0 plus 5 is 0, and 0 minus 1 gives us negative 1. All right, simplify, we get negative 1 is equal to negative 5a. Divide, and we get a is equal to 1/5. All right, last step, we plug it into our equation. We get f of x is equal to a, which is 1/5, times x minus root 1, x minus a minus 5 is x plus 5, and x minus 1. We have the answer to question number 3. All right, moving on, we go to question number 4. Question number 4 is presented a little bit different. This time, they tell you that it's a quadratic function with f negative 2 equal to 6. Associated with a function, we now know that this is x and this is our y value. Because we have given a minimum value, that means it is a vertex. We know that h is equal to negative 8 and k is equal to negative 1. As you probably hear, I'm doing this after school, and so we're going to get interrupted by all these nice announcements. All right. F of x is equal to a times x minus h. Well, we're going to plug in all of our information, and we have 0 plus 8, because we're dealing with at the y-intercept, so we know our x is equal to 0. We have squared, and then we are adding a negative 1. All right? Our y value is equal to 6, so I guess I'll write it out here, 6. All right, so what we have is a times 8 squared. 8 squared is 64, so we have 64a minus 1 is equal to 6. Basic math, we now have 7 is equal to 64a. And what that tells us, our a value is equal to 7 divided by 64. So plugging the information into the quadratic function equation, we get f of x is equal to 7 over 64 times x plus 8 quantity squared minus 1. There is our answer for problem number 4. Flipping over to the next page, we'll start with problem number 5. And as I'm sure you were told, we're not going to do problems 6, 7, and 8. Those will be gone over and taught after the test, and we'll have a test specifically dealing with word problems with quadratic equations. All right. Number 5, it reads, write the equation of a quadratic function with f of 3 equal to 4. So that is our x and our y value. So our x is equal to 3 and our y is equal to 4. And because it is a maximum, that's our vertex. So we know that h, hold on just a minute, I need to make this guy a little bit wider so y'all can see the problem. Hold on just a second. All right, we moved it over, our letters shifted, so let me rewrite that. Our x value is 3, our y value is 4, and since they told us this was a maximum value, we know this is h, we know this is k. All right. Now that we have all of the information we need, we're going to use the vertex form of the quadratic equation again. We're going to plug in our y value is equal to 4, and that's equal to a times, once again at our y-intercept, 0 is x plus 1, quantity squared, plus 10. We do the math, and 1 squared is 1, 1a plus 10 is equal to 4. We subtract, we do the basic math, and we get negative 6 equals to a. I don't need to show you all of that work. Y'all are too sharp, right? All right. Now we go to f of x. We just plug in the information that we just calculated, and we get f of x is equal to, excuse me, f of x is equal to negatives. Oops, what happened? Hey, get out of there. Escape. Negative. Get back to my pen. There we go. X is equal to negative 6 times the quantity x plus 1 quantity squared plus 10. There is our final answer. Let me flip the page over. Hold on just a second. Okay, problem number 9. The easiest way to take care of these is we're adding function f, so I'm going to put it in parentheses, f 5x squared minus 3x. Okay, that's function f, and we're going to add to it function g, which is x plus 2. We're now going to combine like terms, so we have 5x squared, we have minus 3x plus x gives us a negative 2x, and we're left with positive 2. So the answer to 9a is 5x squared minus 2x plus 2. Okay. On question number B, 9b, this is the same thing as writing it as f composite g evaluated at negative 3. All right? So what that means is let's evaluate g at negative 3 and see what we get. What we get is negative 3 plus 2 is equal to negative 1. Now that we know what g of negative 3 is, we plug that value into the function f. So we're going to evaluate f at negative 1, and when we do, we get 5 times negative 1 squared minus 3 times negative 1. 5 times negative 1 squared, that's 5. Minus a negative 3 is the same thing as adding 3. So the whole composite function, the value is equal to 8. All right. Moving on to 9c. We're subtracting two functions, and I think it'll help you guys out if you write things in parentheses. So we have 5x squared minus 3x, and we are going to subtract, ooh, that was a long subtraction, g of, let me clean it up a little bit. Got ahead of myself. There we go. We're going to subtract x plus 2. All right. Combining like terms, there's nothing to combine with 5x squared. We have negative 3x minus another x, so we get minus 4x. And we are subtracting a positive 2, so it is minus 2. So f minus g evaluated at 2, we need to now plug in the value of 2, and we get 5 times 2 squared minus 4 times 2 minus 2. All right. What that is, 5 times 4 is 20. 20 minus 8, minus 2 more. In the end, we get that is equal to 10. All right. Problem 9D. This reads G composite F evaluated at X. What we're going to do is we're going to plug the function f of x into the function g. So the function f of x is 5x squared minus 3x. We are plugging that into the g function anywhere we see an x. So we've got 5x squared minus 3x. The rest of function g is plus 2. Now all we need to do is simplify. There's not much to simplify. We have 5x squared minus 3x plus 2. That is your final answer. Moving on to problem number 10. This is basically a review problem from the last test. They give us 2 points, -2 and 6, and 4 and -3. First thing we should do is determine the slope. And to determine the slope, we're going to take y2, -3, minus y1, which is 6. We're going to divide that by x2 minus x1, and because it's subtracting a negative, it became positive. When we simplify that, we get -9 over 6. Simplifying the fraction, we get -3 over 2. All right, so we know our slope is -3 over 2. What we're going to do is we're going to say -3 over 2 is equal to y minus. Pick either point. It doesn't really matter. I'm just going to pick the first point up here, and I'm going to say y minus 6 over x minus a -2, so that's x plus 2. All right. We're going to use our cross products, basically cross multiplying, and when we do, we get 2 times y minus 6, and that equals -3 times x plus 2. Promethean board's not calibrated, so I have to deal with that. What we have here is 2y minus 12 is equal to negative 3x minus 6. All right, go through, move the 12 to the other side. We have 2y is equal to negative 3x plus 6. Go ahead and divide everything, both sides, by a positive 2. And when you do, you get y is equal to negative 3 over 2 times x plus 3. That is our final answer. And if you'll notice, the negative 3 over 2 slope is the same as the negative 3 over 2 slope that we calculated at the very beginning. The next is a simple problem. It says, give the slope of a line perpendicular to the line in problem number 10. Well, in order for two slopes to be perpendicular, they have to be opposite reciprocals. And basically what that means is you take the slope and flip it and change the sign. So the slope of a perpendicular line to the problem in number 10 is simply positive 2 over 3. There is your answer. All right. So we've gone through the entire review. I hope that was helpful. Good luck on the test.